Okay, so here we have one more example for construction of KD tree. Here we assume that the KD tree to be constructed is going to store the points inside internal nodes as well as inside leaf nodes. So this is the given data set. Again, as we know that initially we have to partition the space on the basis of one of the coordinates. So let us first partition on the basis of X coordinate, and in order to partition, we require to identify the median node. To identify the median node or the median point, we have to sort the points on the basis of their X coordinates. So after sorting, this is the list that we have. And the median for this particular sorted list is 6, 7. So as you can see in the generated tree, this 6, 7 becomes the root node. After identifying the root node or after partitioning the space into two halves, now we have to recursively partition the remaining left and right set of points. So now the next partitioning will be based on y coordinate. So let us now sort these points and these points separately on the basis of y coordinate, and after sorting the points on the basis of y coordinate, the point from 1 to 6, this is what we get. Similarly, we sort the points from 8 to 13 on the basis of their y coordinate, and after sorting, this is the generated list. Now among these two, again we identify the median. So the next median we get is 5, 2 and 8, 5. So 5, 2, because it is present to the left of the partition space, so 5, 2 becomes the next root of the left subtree, and 8, 5 becomes the root of right subtree. Okay, now in the next level, as you can see in the figure, initially we partitioned on the basis of X, next we partition on the basis of Y, and again now we have to partition on the basis of X. So let us now try to find out what we get to the left and right of 5, 2. Now if you observe here, the points that we have to the left of 5, 2 are 3, 1 and 2, 2. So now the sorting will be done on the basis of X coordinate, and after sorting, these are the points that we get, that is 2, 2 and 3, 1. Similarly, after sorting these points on the basis of their X coordinate, we get 1, 8, 2, 6 and 4, 4. And now let us identify the median. So because we have only 2 points, so again, as I told you that you can consider any of the points as median. So let us consider the first one. So 2, 2 becomes the next root. Similarly here, the next root that we get is the median 2, 6, as you can see in the figure. And after that we are left with only 1 point, that is 3, 1, which is to the right of 2, 2. So it becomes the right child of 2, 2. And if we consider 2, 6, then to the left we have only 1 point, that is 1, 8, and to the right we have only 1 point, that is 4, 4. So here we get a 4, 4. Similar type of partitioning will be done on the left and right of 8, 5. And after partitioning on the basis of X coordinates, we next get 7, 3 and we get 9, 7. And this is how the tree get constructed. Now this particular KD tree is also called as a 2D range tree. So if you are asked to do 2D range tree construction, you can use the same procedure. And if we want to represent it in the form of KD tree, so this change we can do. Now what is the change done here is, only note that all the internal node points are written outside the node. Like here 6, 7 was written inside, here it's written outside the node, and inside the node we just have to represent the direction of the cut. That is the dimension we are using for partitioning. Like first time we go for X coordinate, so this is vertical split, and when we go for Y coordinate, it's a horizontal. So this is X, Y, X, and so on. So this is the generated KD tree. Now let us now see how to perform a search operation, that is the algorithm for search on this particular KD tree or range tree. So suppose we want to search for 1 8. So search is going to be same as the basic search in binary search tree. Only difference being that at a particular level, we will be comparing only one of the coordinates. Like when we are at root, we have to compare the x coordinate. Then on the next level, we have to compare y coordinate. Then on next level, compare x, then y until we reach the desired node. So let us try to search for 1 8. Initially, we compare the x coordinate, that is 1 with 6. Because 1 is less than 6, so we continue the search on left subtree. Now when we reach on the second level, we have to compare y coordinate. So the y coordinate of this point is 2 and this point is 8. Because 8 is greater than 2, so we have to continue on the right subtree. Because we are down to the next level now, again we have to compare the x coordinate. So let us compare 1 with 2. Because 1 is less than 2, so this value must be to the left of this node 2 6. So again continue to the left, and finally we find that the values are matching. So we can declare that the value is found. Now let us try to search for 7 8. Again start the search from root node. 7 is greater than 6. Go to the right. Now compare the y coordinates. 8 is greater than 5. Continue to the right. Now compare the x coordinate. 7 is less than 9. Continue to the left. Now compare the y coordinate. So here we will not compare any coordinate because we have reached the leaf node. So no further partitioning is possible. So we directly compare the value with the search key. So here we find that the x coordinates are matching, but y does not match. So here we can declare that the key that we are searching is not present in this range tree or KD tree. Same type of procedure you may apply on this tree also. And you can explore this, the construction of this KD tree space. We already know how to construct this. So first we have 6 7, then we have 5 2, then we have 8 5, then we get 2 2 and 2 6. So you can see here we have 2 2 and 2 6. Then we get 7 3 and 9 7, and then finally we are left with the leaf node. So you need not show further partitioning. Okay.